Hi everyone. This is the second video for terrain model and 2D computational mesh in HEC-RAS. In this video, I will create and edit two-dimensional flow area and compute hydraulic properties on that. After that, I will show demonstrations how to refine a 2D mesh using break lines and refinement regions. Before starting this tutorial, we need to check our working directory. Since we developed this terrain model using RAS mapper, you can see this new file was generated on this working directory. So this .ras map, okay? So let's go to this RAS mapper and make a big screen to see more clear the terrain model. So if you are available, right click and zoom to layer. Okay. Then go to select geometry and then just expand this geometry. So now you can see this 2D model we already created with the geometry file on this directory on here. Okay, last video we already created on here. So in this case, I will develop 2D areas, two-dimensional areas on this terrain. So please right click and edit geometry. Okay, and then please select this 2D flow area. Okay, and then expand this one. After that, just click perimeter. After that, you can see this tool, add a new picture. Icon is activated. So now you can add a new picture. So let's start from this point and then just make some areas to make meshy. So this is very same way to develop the lever. But in this case, you can see the linked these lines. So I will create some perimeter for two-dimensional mesh. So I will make 2D mesh along the distinctive areas for this terrain model. Okay, so you can do some differently with my created one. For your preference, you can take some different regions with this terrain model. Okay, so let's continue, create the perimeter. In this video, I just want to show you how to create this 2D mesh and how to refine the 2D mesh. That is the intention of this tutorial with this video. So I think I should stop in here. In this case, you need to double click on here. And then you can find this box to give the perimeter name. So I will give 2D area for this perimeter. And then click OK. Now we are just created this two-dimensional area with this perimeter. So on here you can right click and then just find this edit to the area properties and click. So then you can find this 2D flow area editor you can bring and then just to make different spacing with the points. Okay, so I will use 200 feet for this the spacing. So from this default 100 feet, I will change this as 200 feet. And then you need to create this button, generate computational points. So just click and then you can find some differences on here. After that, I would like to make one more differences on this Manning's M value from 0.06 to 0.04. Okay. After that, you need to click this close button. Now we are developed this 2D mesh. After that, now you need to inspect all these created the boundaries with this mesh. Any mistake you need to find. So in this case, you need to click this computation point. Okay, and then also find only one point should be in here, this one mesh point, one grid. Okay, so I think it is okay to develop. I think I don't have any mistake for this mesh. So in this case, also if you have any mistake on here, you can edit with this new add features as well as this edit features button. Okay, so in this point I would like to stop this. So right click perimeter and press stop editing and then save. Yes. Now we are finally succeeded to develop this 2D mesh. So now I will compute hydraulic properties developed this mesh. So you need to go to this 2D flow areas and then right click. You can find compute 2D flow areas hydraulic table. Just click. And then you can find this status window. So it already completed with this hydraulic property computation. Okay. After that, you need to go to all the different cell and this perimeter, the cell perimeter. You can select. So we can call this would be cell and this the cell face. Okay, so in that case, just select any of this cell face, and then right click to see this property table, and then you can find many different things on here. So in this case, I would like to see base profile. Okay, so just click and then you can bring this cell base profile. Okay, so let's move all these different cell base profile. Maybe you can find this shift of all the cell face with this profile. Okay, so you can find the elevations for these profiles. Okay, so you can understand what we've done with this mesh, and then go to, how about this, select this cell volume versus the elevation. So maybe this cell hold this kind of the this volume and elevation. Okay, so you can also find all the different things in here. You can find the base area versus elevation, area and elevation. So you also find with the different cell face. Okay, and then let's see this weighted parameter and elevation, Manning's base Manning's n versus elevation. So I'm not sure, this is not much difference. So because we assigned all this Manning's value with 0.04, okay, then some conveyance with elevation. This conveyance with CFS you can find. So also this is effect for cell face. Okay. Lastly, face profile we checked very firstly. So with this after computational this flow area hydraulic table, we can find many different hydraulic properties on this cell and this cell face. All the created cell, you can find that kind of hydraulic properties. So again, we can review all the created hydraulic property cell for the volume and elevation, and all the different things would be for the face. Area elevation and weighted perimeter with elevation and Manning's and elevation and conveyance and elevation and face profile. So this is our created hydraulic properties for this cell. So in this part 2 video, we just created this 2D flow area with the 2D mesh, and then we just compute hydraulic property, all these different cell-based and different cell face-based the hydraulic properties we computed. Okay. So for the next part 3 video, I will give some refinement with the black line and other refinement area things. Okay. Thank you for watching this part 2 video for terrain model and 2D computational mesh in HEC-RAS.